as you get closer to black holes, lots of weird and crazy things are predicted to occur. What would happen if you fell into a black hole? Well, a weird thing is predicted to occur, and this is called spaghettification. Here's the idea. We've talked about tidal forces in the past. Tidal forces are when there is uneven force of gravity due to size. We talked about this back when we were talking about the planet Saturn. If an asteroid gets too close to Saturn, the front edge of that asteroid is going to experience a large force of gravity, and because the back edge of the asteroid is further away, it's going to experience a smaller force of gravity, and that uneven collection of pulls is going to make that asteroid break into smithereens. And those smithereens, we believe, is what made the rings around Saturn. Well, what would happen if you would fall feet first into a black hole? Well, if you fell feet first into a black hole, similar thing would occur. Force of gravity changes with distance. So if your feet were closer to the black hole than your head, the force of gravity on your feet would be big. The force of gravity on your head would be much smaller. And around your tummy, it would be partway in between. What that means is you would be stretched out like a piece of taffy, and the pull would become so extreme that you would be strung out like a long piece of spaghetti. And so scientists coined the phrase spaghettification. It would not be pretty. It would be kind of icky. And I hope it doesn't ever happen to you or I. It would not be a fun thing to live through. One of the other weird things that happens near black holes is the rate at which time passes changes. Now, Einstein figured this out in a combination of his general and his special theories of relativity. And according to Einstein's special and general theories of relativity, here's how this works. If you were ever near something that is very, very gravitationally heavy, like the Earth, time is going to run slower on your clock than if you are a long way away from that in, let's say, a spacecraft. The force of gravity is actually going to affect how fast or slow time falls or passes. And so what that means is if you were traveling close to a black hole, your clock would run a lot slower. So much slower that you would actually age much more slowly than someone that was be a distance away. You would age very slowly, and let's say your compatriot out here would age much faster. That is why there is the idea of relativity. What you observe for how fast time passes is related to the strength of the gravitational field that you happen to be in. And I'm going to try and ignore my phone. How's that for a deal? So what would happen if you fell into a black hole? Well, let's say you don't fall into a black hole. Maybe you're out here someplace in your happy little spaceship, and one of your colleagues was a little bit crazy and got within that event horizon and was going to fall through that event horizon into the black hole. Because of the fact that they are closer to this black hole, time would fly for them very, very slowly. And because you are a smart astronaut and you are a long way away, time for you is going to pass faster. If you look back at your colleague as they're falling into the event horizon into the black hole, to you it would look as if their time had stopped. It would be kind of weird and kind of creepy because it would take almost forever on your clock for your friends to fall into the black hole and die. It'd be kind of goofy, I think. But the people who are actually in the spacecraft near the black hole, they would experience a massive acceleration of gravity and they would go phew, and they would actually get squished into smithereens almost instantly. So you wouldn't have to worry that they were in pain for a long time. They would very quickly get spaghettified and squished by that black hole. Now, if, as they were falling into the black hole, your colleagues over here could look back and see you, they could actually see that time for you was traveling so fast, they could watch you age. So as they watched, you could be a person in your 20s, 30s, 40s, and from their viewpoint, right on the edge of that event horizon, they would see you grow very old very quickly. This is, again, one of those weird concepts of Einstein's relativity. One of the most famous stories about relativity and time is the concept of what is referred to as the twin paradox. The twin paradox says this. Let's say there were two twin brothers, and one of them, we'll call him Speedy, one of them went traveling around the universe very, 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 very quickly. The other brother, let's call him Slow. The slower brother stayed on planet Earth and did not travel fast. Well, maybe 20 years later, according to Speedy, 20 years passes, and he says, hey, I miss my twin. I want to come back to Earth and visit him. And when he visits his twin brother, maybe for the guy in the spaceship, 20 years has passed, but the fellow who stayed at home, the slow brother, maybe 60 years has passed. How much time distance there would be? Well, that depends on the speed at which the astronaut Speedy actually traveled. It's again an example of Einstein's relativity and the concept that time is going to travel at a different rate depending upon where you are and how fast you're moving. There's the movie Interstellar. Interstellar is a movie that came out a handful of years ago, and this movie uses the concept of Einsteinian relativity as part of a plot twist. The Matthew McConaughey character goes traveling out in the universe to save mankind. He spends some time next to big gravitational objects and eventually returns home. The people he left back home started out quite young, and when he sees them again, much more time has passed, and hence they're trying to use this concept of relativity. Here's a little video on black holes. Depends on which one I'm going to ask you to see. Hopefully, you're going to see one or the other. All right, guys, we're going to quit right there and come back next time and continue. We'll see you later. Bye.